Okay, so problem one is let f of x equal x squared and g of x equal 3x, and let R be bounded by the region in the xy plane between the graphs of f and g. Set up an integral for the volume V and of the solid generated by revolving R around the line y equals -1, and don't evaluate the integral. So first what you want to do is look for what is the volume equation. So it's asking for volume, right? Volume. So you're going to set up the volume equation, which is V equals pi times the integral of b, well, a to b, and the bounds are r times x squared dx, right? And then there's also, that's the disk method. So this, put disk. And then there's the washer method, which is v, you could do this, or the washer method, v equals pi b f of x squared minus g of x squared. And remember, it's always going to be like the bigger circle minus the smaller circle. So for step one, what you're going to want to do is you're going to want to take this graph. So you've got these two functions right here. So you got f of x equals x squared and g of x equals 3x. So for step one, let's label it. Step one, you're going to have the graph. It's a simple graph. So this is obviously the graph of x squared. And then this is the graph, since it's a linear graph, this is the graph of 3x. So in between this, you're going to want to get what's in between here. So that's step one. Step two is you're going to want to place these, now that you got them, you're going to want to place them into the formula as was done earlier. So you're going to set it up like this. V equals pi times, we don't know what the bounds are yet. We're going to find those, but we're just going to like slowly chip away at this formula. F of x, so f of x is x squared. But it's the f of x is x squared. But it's the bigger one minus the smaller one. I'm just going to go with the way it was done. 3x squared minus x squared. And I don't think they're x squared squared, actually, since g of x squared and then dx. And usually I don't think there's like a right or wrong way to do this. Step three, now you're going to want to so for step three, you're going to want to find the bounds. So what you do is you set f and g equal to each other. So you set f of x equal to g of x. So x squared equals 3x. This x squared minus 3x equals 0 is what you're going to end up getting. And so you're going to want to factor out an x. So it's going to be x times x minus 3 equals 0. And then you're going to get x equals 0. And then x minus 3 equals 0. You're going to end up getting x equals 3 here. And these two things are your bounds, x equals 0 and x equals 3. So step four. Only 5 steps here, so we're almost done. And you don't have to set up you don't have to solve the integral, you just got to set it up. Step four. Now we got our whole thing going with pi. Pi 3 to 0. We got the bounds in. We got 0 to 3 with their bounds. 3x squared minus x squared squared. And notice how I'm not putting x to the fourth. I don't want to do that because if you had to solve this, it would have like confused you, like, oh, like something may go wrong. So I'm not going to do that just yet. So step four, you set up the integral, but we're not just done yet. Remember, we got y equals -1 here. So we're going to have to add that. So step 5, we're going to add y equals -1 into this problem. So how do we do that? So we're going to now have v equals pi. And remember, this is probably one of the most simple equations on the final exam that you're going to get. Plus 1 squared. So you're going to want to add 1. This is what I was taught to do. Add 1. And then it gets a little confusing with that part where you got to add 1, right? X squared plus 1 again. And then square that, and then dx. And this is your answer. Boom.